What's the value you got?
So 27,000.
27,000 is without the initial distance it has traveled, right? Now it's okay, you can do it as 3 stages, but better thing to do is use this one, S0 plus VT. So this S0 is 900. So the total distance from the start is how much? This will be 27,900. Okay. Both are okay. You can find the values separately and then finally add them up, or you can use the equations with the initial distance and get the answer at the end directly. Right, what about stage 3? What do we know about that one? For the stage 3, we know the initial velocity for that stage, we know it is same as this 30 meters per second, right? And also we note that we at the end, let's say VE is 0 because the train is going to stop. And then what else we have? Is there anything else given? Yes, we know the initial distance at this stage, which is 27,900, right? And also we know the acceleration as minus 1 meter squared per second. So these are the things we know. Again, we can use the same equations to find the distance traveled. S is S0 plus V0 T plus half AT squared. Only unknown thing here is the time, right? To find the time, what we can use?
Excuse me, sir.
Huh?
So can we use the V squared equals
That's okay. If you want it to go it like that, that's fine. Right? If you want to go in this way, so we can compute time from V equals V0 plus AT. The final velocity is 0. Initial velocity is 30. And A is minus 1 times T, and which will give you the time as 30 seconds. If not, you can use the equation without time. Once you have this, apply all the values in here, and you can find distance traveled. What is the final answer you got?
$28,350 meters.
Okay, correct. Anyone who has find it difficult to compute this value? If you have any doubt or question, you can ask at any time. Okay, then let's move to the next one.
Sir, excuse.
Yes.
Sir, S equal to S naught plus 2V naught T plus half A T squared in this equation.
Which one?
2V naught, sir. 2V naught T. Constant velocity is S equal to S naught plus V naught T, sir. Then deaccelerating V naught T plus half A T squared.
Yes, that's what you had to add.
So we can add the against V naught T, sir. S naught plus 2V naught T.
S naught plus
2V naught times T, sir. 2 times V naught T.
how do you know that?
So constant is a constant velocity. S is equal to S naught plus V naught T. Decelerating S naught plus.
No, you can't do it because this is a different stage. The function is not continuous. At the first stage, you have acceleration, right? Then it is a constant velocity. And last stage, again, you have deceleration. So these V naught are not the same. Okay. This V naught is only for stage 3. So don't get mixed things up. I wrote it as V naught because this is the standard form of the equation. Here you have to use initial velocity for this stage, right? You can't get the previous one and it here. Any question?
Thank you, sir.
This really is motion of 3 different sets. Only thing we know that at end of each set, it is the starting for the next stage. Right, let's go to the next one. Okay, third question. Ball A is thrown vertically upward with velocity V naught, right? Ball B is thrown upward from the same point with the same velocity after t seconds, right? Determine the elapsed time or the total time from the ball A is thrown. And the time they need is to when the ball passes each other, and also you need to find velocity of each ball at this instant, right? Can you understand what it happens? You first throw one ball up, right? Then you went for t second, and after a second you are going to throw up the second ball, right? So when you have two balls flying at one instant, they may pass each other, right? This will always happen if you put two balls up. Why is that? Why they are going to pass each other? Because this is motion under gravity. So it doesn't matter when have you thrown up A earlier, it will move up and comes down. So at any instant, these two must meet. Why the condition 2v naught over g is given? What is the importance of that one? It says t is less than this amount. If not, what will happen? A has already come to the point where you throw it up, right? So A is at the same point. If that happens, yes, they are not going to meet each other. But here it says that A has not yet comes down to the initial position. Okay. So here again, you can use the equations for the motion under constant acceleration. And there is only one acceleration. It is the gravity. And the other thing is, this is a one-dimensional motion. So can you try? First, mark all the important things about this question and then start doing it. Think how you can do this. So let's mark what is going to happen in this situation. First, you are going to throw ball A up. Right? You will throw it up. It's going to go up. And it reach the maximum height and it start to come back. Right? And after 3 seconds, you are going to throw ball B up, right? So it is going to move up. And at a certain height, these two should pass each other, right? Because as I told you, we are going to throw ball B up before A moves up and again pass this point. If that happens, they will not meet. But here we are going to throw B up earlier than that. So let's suppose the height where they are going to meet is H, right? So A is thrown up at the velocity V naught, B with the same velocity, and we have only one acceleration, which is gravity, right? And the time between A and B throwing up is given as T. So what we're going to do? This is all the question says. Any idea? What you plan to do? Now here again, the important point is that when they meet each other, right? At that particular point, the important thing is both A and B is h distance away from the origin. So starting point, right? So that is what we are going to use, right? So if we are talking about the same distances, what the equation that we are going to use? S is S naught plus V naught T plus half A T squared, right? You are going to apply this equation for A and then for B, right? If we consider the motion of A, right, when the two balls meet, what is the distance that A is from the origin, which is the S, is H, right? So it has H distance away from where it starts. And what else we know about A? We know that initial velocity of A, I wrote it as VA naught, is given as V naught, right? And A start from the origin where we're going to measure it. SA0 is 0, right? And SA that we want is H, and the time T is the time between A and B, not the total time from A or total time from B. So let's measure the time that A is flying as t dash when A and B meet, right? This is the total time that A has taken to meet B. And we have the acceleration, which is g, and it is in the opposite direction. Now apply this equation for the motion of A. You can write SA is equal to S A naught plus B A0 into T plus half acceleration of A into TA squared. Then replace these values. SA is H, SA naught is 0, VA naught we have given as V naught, time A is in motion is TA. No, we took it as T dash, right? To simplify things. So this is T dash minus R G T dash square. When you do the simplification, you should get V naught T dash minus G over 2 T dash squared. Then what we're going to do, we know that when they meet, B should travel the same distance. So let's apply this equation for B. So we are going to consider motion of B. When the two meet. So what about B? What are the things that we know? For B, we know that just like for A, B0 is V naught. And we know that the distance at the initial is at the origin. And when they meet, the distance traveled by B is h. And acceleration is minus g. And what about the time? TB is how much? T dash is the total time for A. We know that B is going to start after T seconds. So we can write it as time taken by A minus T. Right?
Excuse me, sir.
Yes.
Sir, the ball A is going downwards, right? Coming
Yes.
down, and the ball B is moving upwards.
Yeah.
So, sir, the acceleration of free fall, the G should be positive to.
No, we
A.
are not going to consider the direction of the G here. G is always downward, whether ball A is going up or down. Right? That is why it is considered, and we can apply the equations of constant acceleration.
So we are taking both are moving upwards, the direction.
We are measuring direction upward. That doesn't mean both of them are moving upward.
Upwards. Okay. Sir. Okay. Thank you. Sir.
Right, now apply the same equation for B. Now let's try it. So SB equals SB naught plus VB naught into TB plus half AB into TB squared. So SB is H, SB naught is 0, VB naught is V naught, TB is T dash minus T, and AB is minus G over 2 T dash minus T squared. From here you will get H equals to V naught T dash minus T minus G over 2 T dash minus T squared. Now we have two equations, one from the motion of A, which is this one, and one from the motion of B, this is this one, and you can see that both of them gives you the same height. So we can equate them together and solve for total time T dash. So I can write V naught T dash minus G over 2 T dash squared is equal to V naught T dash minus T minus G over 2 T dash minus T squared. Now to find T dash, what you need to do? Solve this equation. So take few minutes and try to solve it. Were you able to solve it? Even though it looks like a quadratic equation, it is really not quadratic equation of t dash, right? Because you can see in both sides, gt dash squared is going to go out. So when you expand this side, what you're going to get, v naught t dash minus v naught t minus g over 2 t dash squared minus 2 times t dash plus t dash squared, right? So this side we have v naught t dash, and on the other side we have v naught t dash. So we can remove those two terms, this one and this one. Then here we have minus g over 2 t dash squared, and here also we have the same quantity, so this is go out. What is going to remain is 0 equals minus v naught t plus g t dash minus g over 2 t dash squared, right? So I am going to take the unknown, which is not t dash, this is t, right? Yes, this one is t. So here you don't have t dash, right? We have t dash squared. Here this is t squared. Unknown is this one, that into one side, gt t dash equals v naught t minus g over 2 t squared, and t we can remove, is not going to be 0. So we have gt dash v naught minus g over 2t. We can multiply everything with t, 2. So 2 gt dash equals 2 v naught. This is not minus, right? This goes to this side, it should be plus. Both are having the same sign. Plus gt. So t dash comes as 2 v naught plus gt over 2g. Is that what you got? Or any other different answer? Now we have the total time. And then what are the things the question asks? So the total time, we have it. And then it asks the velocity of each ball. So how to find that? You can apply v equals v naught plus gt. For ball A and for ball B, which will give you the two velocities. To find velocities, we are going to apply v equals v naught plus at for a va naught is v naught, which is given. Acceleration of a is minus g, and time for a is how much? T dash, which is 2v naught plus gt over 2g, right? Now apply these values in here. So you get v as v naught minus g 2v naught plus gt over 2g. Then v naught minus v naught minus g over 2 times t. So v naught will cancel out. We got this one as minus gt over 2. So what this minus sign mean? That means the VA is actually gt over 2 downwards, right? Then do the same thing for B. Yes.
No, sir, the paper wasn't visible. Now it's visible.
Now do the same thing for B. The only difference that you have to make sure is TB is how much? T dash minus T. And you will see that you will get a positive value, which means it is still moving in the upward direction. So what the value you got for B? Still doing? It is not that difficult. How much is VB?
Uh, 3GT over 2, sir.
Huh?
Sure about the answer. 3GT over 2.
GT over 2 and the reaction?
It's I got a positive.
It is upward.
Yeah.
So the answer
Upward.
is correct. Right? When you do that, you should get VB as GT over 2 in the upward direction. Anyone need my help? It really there's nothing to do. Only thing is replace this T dash with the value you found. Now it is 10 o'clock. Let's take a 10 minutes break and meet again. Should we have another class on the next day, or you don't need any more classes?
We need one, sir.
Huh?
We need
We
one,
need-
sir.
He needs.
Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
The only problem is that can we start little bit late, like around 9 or 9:30? Is it too late?
Okay, sir.
Huh? Because I have to come to the university, it is not possible to do at home when at 8:30. But 9:30 it will be okay.
We can, sir.
Let's discuss at least around 9. I'll let you know. So for today, let's take 10 minutes break and meet again.
Okay, sir.
You will see that actually when it is with vectors, things are much easier than when you do not have it. So the question says velocity is given. This is a vector 16 t squared I plus 4 t cube j plus 5 t plus 2 k, right? Then we need to find the acceleration. To get the acceleration, what we need to do? We need to get dv over dt. And remember, v is a vector. So when you get d over dt of this quantity, what is the, how much is it? Now here you are in lucky because this is in Cartesian coordinate. In Cartesian coordinate, what is the advantage? I, j, k unit vectors are constants. So when you get the derivative, time derivative of these quantities, I, j, k will be considered as constant and they do not have any time derivative, and only you need to differentiate the quantities with depend on the time. You don't need to worry about these unit vectors, but that is not the case when you have what coordinates? Remember we define ER and E theta, curvilinear coordinates, where the coordinates are going to change with time, right? So here you can just differentiate this one. How much is that? 32 t I plus 12 t squared j plus 5 k. And then the question asks, determine the magnitude of the particle's acceleration, okay, at time t equals 2. So use t equals 2. So this is actually the A, and find A. How much is that? 32 times 2 I plus 12 times 2 squared, which is 4 j plus 5 k, 64 I plus 48 j plus 5 k. This is the acceleration as a vector quantity, right? But the question needs is the magnitude. So how to find the magnitude? A is how much? Square root of 64 squared plus 48 squared plus 5 squared. Do it quickly and get the answer. And for the next part, we need to find the particle's position, right? To get that one, what we are going to use? We know velocity is the time derivative of position vector r. Right, again, this is a vector quantity, so be careful when you do the integration, just like in the previous case. From here, we can get that dr is how much? B dt, right? And we are going to integrate both sides. So this side you get the position vector, and again things are easy because we is in Cartesian coordinates. So you only need to integrate the values which depend on the time. 16 t squared I so when you do that, 16 over 3 t cube I plus 4 over 4 t to the power 4 j plus 5 over 2 t squared plus 2t k, and there is a constant c, but in this case, how much is the constant? The constant also a vector, remember that. But we have mentioned that when time equals to 0, the particle is at the origin. So all three are 0, right? So you don't need the constant c here. We have 16 over 3 t cube I plus t4j plus 5 over 2 t squared plus 2t. Okay. And then to find the position at t equals 2, put t equals 2 and simplify it. And the Cartesian coordinate are the values of I, j, and k.
Sir, can you move the
Okay.
up?
Now,
Okay, sir. Thank you.
Finished? What are the values you got? Only thing you need to do is replace t with 2. And when you do that, the values I got is 42.7 I plus 16J plus 14K. Is that what you got? Which means the Cartesian coordinates are 42.7, 16, and 14. Any difficulty? Shall we move to the next one? Are you guys sleepy?
No.
Let's move to the next one, or you need a little bit more time? So let's see question number 6. In this one, you have a elliptical slot cut in a piece of metal, let's say, and you have a link which will drag the 2 small pegs along this curve, right? You can see that this is the peg, and the link which is going to drag it has a slot in this direction. So these pegs are free to move up and down, and while they were being moved in the x direction, and the speed along the x direction is a constant. Can you see? The link is going to move at constant speed of 10 meters per second. But the motion of the pegs are not going to be a linear motion. Why? You can see that they must trace the shape of this ellipse, right? So, and the equation is given, so things will be easy, right? It asks you to find the magnitude of velocity and acceleration of peg A when the distance from the origin is 1 meters, right? So what are we going to do with this one? I'll give you a few minutes to try on your own. Remember that there is nothing else but the basic of the definition of acceleration, velocity, and the distance or the displacement. So the first thing to do is make a small sketch of this motion. This is 10 meters per second. And this is the peg A. And this curve is given. X squared over 4 plus y squared equals 1. Now the question asks us to find velocity and acceleration. Right? The only option is to do the differentiation, but here you may come across into a small problem. That is, the position vector is not given, but they have given you the equation of the path, right? So how we can get the velocity and the acceleration when you have the equation of the path, right? What we going to do? Any idea? X squared over 4 plus y squared equals 1, right? So what we're going to do is we are going to differentiate this path by respective to time. So let's get d over dt of this one. Of this side, which is 1. So here you will get 0, no problem. But what about this side? How are we going to differentiate this? We have 1 over 4 and the derivative of x squared with respect to x is 2x. And then we are not going to do the derivative with respect to x. We need it to t. So we get dx over dt, or really x dot in our case with our notation. Same thing with y, 2y into dy over dt, and this side we will have 0. So we get half x, and this is x dot, plus 2y, y dot equals 0. Right? Any question up to this? So everyone is fine, right? Now what is x dot? Is the velocity of x direction, and y dot is the velocity in y direction. So I can use that and write this as half x into vx plus 2y into vy. Right? Any doubts? So I hope everyone is fine. And then what we're going to do is, we have the curve, and the question asks us details at particular instant when x equals to 1 meter. So let's apply x equals 1 into the equation of the path. When you do that, the only unknown is y, and we can compute the coordinate of y. So x equals 1 over 4 plus y squared is equals to 1. So on the other side, it is 1. We have y squared as 3 over 4 over y equals 3 over 2. Right? There will be two roots, one plus and one minus, but we are only considering a, and you can clearly see for a, y is always plus. So nothing to worry about the minus value. Then what to do? Any idea? Do we have the value of Vx? Yes or no? Vx.
So 10 ms minus 1.
Yes, Vx is 10. It is given. Right? So Vx, we know it as 10 meters per second. And now when you look at this equation, what we get from the derivative, x we have, which is 1, y we have root through 3 over 2, vx we have 10, and the only unknown is the vy. So put this value in this equation and compute vy. How much is Vy? Still doing?
-5 divided by square root.
Yes, something around 2.8, right? So exactly minus value. Compute it as a decimal, you get 2.89 something. Then how to get the magnitude? Again, square it and get the square root. So here we get Vx 10 and Vy 2.887 actually minus, and the magnitude Vx squared plus Vy squared. So do it. Then how to find the acceleration? Now velocity be done. To get the acceleration, what to do? Again, the same story. Get the second derivative of the path. Right? We have the first derivative, so things will be easy. D over dt half x dot. Only thing, it will be bit longer this time. 2y dot equals 0. Right? When you do it, we have half related to x dot. This will become x dot into x dot plus having x, we get x into x double dot. This is one part, and plus 2. From here we get y dot plus y into y double dot equals 0. I check whether this is correct. So we have half x dot squared plus x double dot 2 y dot squared plus y double dot. Then, just like in the previous case, x dot is really Vx, y dot is Vy. In the same way, x double dot is what? Acceleration along the x direction. Y double dot is the acceleration along y direction, right? So we put those values. Half Vx squared plus Ax into x plus 2 Vy squared plus Ay into y. Again, what are the things we know and what are the things that we do not know? From here, do we know x? It is given as 1. And previous section we computed y, which is root 3 over 2, right? And then Vx is a constant 10 meters per second. And we computed Vy as minus 2.887. Oh, that also there. Then we have Vx, x, Vy, y. What about the accelerations? Ax, how much?
0.
It is 0 because Vx is a constant, right? Vx is constant. That means Ax is 0. And the only unknown is Ay. Right? Now, put these values in this equation, can compute Ay. So this is what you would do if you have the equation of the path. Some things must be restricted, otherwise it will become too complicated. But this is the general procedure. We will stop at 11 o'clock today, okay? I think we have time for another one. How much you got for the AY?
Minus 38.49.
Minus 38 point, yeah, 5, fine. And the magnitude is the same, right? Because AX is 0. So AY is minus 38.49 and AX squared plus AY squared. Then let's try question number 9 because 7 and 8 are bit long. We'll do them on the next day. Let's move and try to finish number 9. So in this one, particle move along path r equals EAT and theta is given as t, where t is in seconds. Plot the path r f theta and determine the particles radial and transverse components of velocity and acceleration. So take few minutes and try this one. So what is this path? Anyone can remember? Radius as E AT. What this will give you? A is a constant. And the other side, you have theta equals T. That means actually what it says is R is E constant time theta. Remember that this is in polar coordinates. What is this equation in polar form? Madagad? This represents a spiral, but this is not the normal spiral. We call this as a geometric spiral. It will move like this. So this is R E A theta, right? In polar form, right? So it is not important to know the path. Still, you can do the remaining things, right? So R is given as E A theta and theta as T. Right? And it asks you components of velocity and acceleration, right? Remember, when we have the polar form, we are going to represent the position vector R as R into ER. Remember this one? Then velocity comes as what? What is the velocity? Can't remember? What's the velocity of this one? R equals R in the direction of R. Remember this one? R dot times E R plus R theta dot E theta. And the acceleration, what will happen? You have, depending on the situation, you will see that some components become 0, but generally r double dot minus r theta dot squared in the direction of ER or the radial way plus r theta double dot plus 2r dot theta dot E theta or the tangential direction. Remember these two? Yes or no? Or is this the first time? Right? Obtaining this one from this is not very difficult. Right? What you need to do is differentiate this with respect to time, and only thing to remember is that unlike in the previous case where I, j, k are constant unit vectors, this ER is not a constant. It also depends on the time. When you do the differentiation, you get two components, one in the radial direction and the other one in the tangential direction, right? We call this as radial velocity and this one as tangential velocity, right? And when you get the second derivative of this one, you end up with little bit long expression, but here again you have this part which is the radial acceleration and this part which is the tangential acceleration. And in this case you have separate names for each of these components. This r double dot is what? What do you call this r double dot? This is the radial acceleration. This part minus r theta dot squared. This is the acceleration, but there is no second derivative term. Instead, you have square of theta dot. What do you call this one? This one you should be familiar.
Angular.
Huh?
Angular.
No, it is not angular acceleration. What do you call this one? This will come when you have the motion around a circle. Circular motion.
Centrifugal.
Centrifugal acceleration. What is this one? R in a double dot.
It's angular.
Huh?
That's
This is the angular acceleration. And this part? And you can see it is very special. There is no second derivative, not even square of the first derivative. It only has two multiplication of radial velocity and the angular velocity. What do you call this one? Right? You don't need to have real acceleration when you have the motion on a plane. Just two different, one in radial velocity and one angular velocity is enough to have an acceleration generated. And what do you call this one? This is called as Coriolis component. Right? So in this question, what you need to do is differentiate this one and find these values and put them to the equation. Then you can compute all the things, and here theta is also given, right? Theta is t. So you can differentiate everything and put in for V and for A, and you will get the magnitudes for V and A. We will stop for today, right? And let's try to meet somewhere on maybe next week. When do you have exams? First phase?
18th of January, sir.
Okay, then you are not very busy these days, right? Let's arrange another one maybe next week. Is it okay to have it in the evenings, or you want to have this in the normal hours, like in daytime?
Anytime fine, sir.
Yeah, some may be working. That's why I had it in the night.
So evening is fine.
Huh?
Evening is fine, sir.
Evenings are better.
Yes, sir.
Okay. Only thing is that my kids will not allow until they go to sleep. So we can start a little bit late, 9 o'clock.
Okay, sir.
Okay. I'll arrange and let you know.
Okay.
And if there is any question, just send me an email or you can ask, right? But try to do these problems on your own